Hello, this is Mr. Wynn, and we have lesson 10-1, sequences as functions. First, we're going to do arithmetic sequences. A sequence is a set of numbers in a particular order or pattern. Each number in the sequence is called a term. The sequence can be finite, meaning it stops. You can count everything inside there. Or it can be infinite, or that goes on forever without end. For example, right here it has a dot, 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 keeps going. The first term of a sequence is denoted as a sub 1, the first term. The second will be a sub 2, third will be a sub 3, and so on. Here's some words and the key concepts. Sequence is a function which the main is just the natural numbers, and the range is the real numbers. The domains can be position terms for the first number, second number, third number, fourth number, and so on. And then the range will be the value of that number. So a sub 1, whatever that is, a sub 2, a sub 3. Here's some examples. Here's finite, meaning it stops. Domain, there's 1, 2, 3, 4, 5 spots, so 1 through 5. Range, it's the values. It's 3, 6, 9, 12, 15. Same thing for infinite sequence. Domain, all natural numbers, because 1, 2, 3, and goes on forever. The range, multiples of 3, as you can tell. Anyways, in an arithmetic sequence, each term is determined by adding a constant value to the previous term. This constant value is called the common difference. It can be positive or negative, so basically we're adding or subtracting. Look at this sequence, 3, 6, 9, 12, 15. This sequence is arithmetic because the terms share a common difference. Each term is 3 more than the previous. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. Alright, so here's the first example. Identify whether each is an arithmetic sequence or not. I define the common difference. So you do the second term as the first term. So I'm going to do negative 6 minus 5, that gives me negative 11. So I think this is a minus 11 for each term. I'll try the next one. So negative 17 minus negative 6. We subtract negative, that's really adding. So that's negative 11, that's good. I'll try another one. Negative 28 minus negative 17, again adding. It's negative 11. So yes, it's arithmetic with D common difference is negative 11. I'll try this next one. So 12 minus negative 4, it's really adding, that's 16. So I think it's plus 16. I try the next one. 28 minus 12, that's 16, that's good. Try the next one. 42 minus 28, that's 14, that's different. So no, it's not, because it's not a common difference. It changed. It went from plus 16, then plus 14. Alright, so make sure you know the difference. So once you know the common difference, you can find more terms if it's continuous. So consider sequence 18, 14, 10. Find the next 4 terms. So first we have to find the common difference. So 14 minus 18 is negative 4. So we're subtracting 4. So that should be pretty obvious. So I have 18, then went to 14 because they subtracted 4, then went to 10, then went to find the next 4. So I'll write this. I'm going to do minus 4, gives me that. Minus 4, if I subtract 4 again, that gives us 6. Subtract 4 again, 6 minus 4, that gives us 2. Then I do it one more time. 2 minus 4 gives us negative 2. Is it 4 terms? One more. Alright, so one last time. Subtract 4 again. That gives us negative 6. Alright, and now we're going to graph them. So the domain is 1 through 7, and then the range 18, 14, 10, 6, 2, negative 2, negative 6, which I found. And here's the graph. Notice what it makes. It makes a linear line. So notice that the graph of an arithmetic sequence lies on a line. And the sequence is a linear function in which the term number n is independent and the term a of n is a dependent variable, and the common difference is the slope. So let's try this. During a routine, high school marching band marches in rows. There's 1 performer in the first row, 3 in the second, and 5 in the third. This pattern continues for the rest of the rows. How many performers are there? In the 14th row. So first we have to find the common difference. Hopefully you can see it's 1, then 3, then 5, and keeps going. So our common difference, our D, is going to be 3 minus 1, which is 2. We're adding 2 each time. So we're adding 2 more. From there, we have D equals 2, but in this case, until the D I'm called M, that's our slope. It's increasing 2 per row. We need a point. We can pick any point. Our points available are 1, 1, 2, 3, and 3, 5. I like 2, 3. Row 2 has 3 people. And we can use our old trusty point slope form. Y minus y1 equals m parentheses x minus x1. So I'm going to fill this in. Remember, this is your x1, y1. So when I plug it in, we get y minus 3 equals m, which is 2 parentheses x minus x1. We're going to distribute. So y minus 3 equals 2x minus 4. I'm going to add 3 to both sides. I get y equals 2x minus 1. Now that I have our equation, let's plug in 14, because it's 14 common question mark. So when x is 14, what's y? So we're going to do y equals 2 times 14 minus 1. That's 28 minus 1, which is 27. There's going to be 27 people in the 14th row. And we could count, it'll take a long time, but 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27 for the 14th row. Alright, besides arithmetic sequences, we have geometric sequences. It's another type. In a geometric sequence, each term is determined by multiplying. So instead of adding, we're multiplying by a non-zero constant to the previous term. That constant value is called the common ratio. So instead of common difference, D, we have a common ratio, R. So look at that sequence, 1/16, 1/4, 1, 4, 16. It is geometric because each term share a common ratio. Each term is 4 times as big as the previous one. So, for example, 1 4 times 4 is 1, 1 times 4 is 4, 4 times 4 is 16. They all are multiplied by 4. Alright, identify these, whether they're geometric or not. So all you're going to do is, like before, instead of doing the second term minus the first term, I'm going to do the second term divided by the first term. So here I'm going to do 6 divided by -2. That gives me -3. So it looks like my multiplier is -3, but I checked doing the rest. So third term divided by second term, -18 divided by 6. That's -3. That's good. Let's try one more. 54 divided by -18. I get -3. So yes, this is geometric. And the common ratio is R equals -3. Alright, down here, I'll try the same thing. So let's try the first one, 16 divided by 8. Well, that's 2. Sorry, 16 divided by 8. That's 2. So it looks like it's doubled. Then I try the next one. I get 24 over 16. That is, let's see, 3 over 2 divided by 8. 3 halves. So that's different. That's 2, 1.5. Because they're different, they do not share a common ratio. This is not geometric. Alright, knowing the common ratio can help you figure out more terms. Just like if you knew the common difference, you can find more terms. So here's this geometric sequence. Find the next 3 terms of the sequence. So let's find the R first, the common ratio. Second term divided by first term. I can do that to 1/4. I'm going to check the other one just in case. 2 divided by 8, that's also 1/4. That's good. So we know R is 1/4. All we do, that's our multiplier. So I'm going to write how I did earlier. So we have our first 2 terms. We have 32, then we have 8, then we have 2. And to get that, we had to times 1/4. Now, hopefully I know times 1/4, the same thing as divided by 4. So I times 1/4, or 8 divided by 4 is 2. I'm going to do it again. So, times 1/4. So 2 over 1 times 1/4 is 2 over 4, which reduces to 1/2. Then I'm going to do it again. So times 1/4. 1/4 times 1/2 is 1/8. Then one more time, because it's 3 terms. 1/8 times 1/4 gives me 1 over 32. Alright, so those 3 next terms. We're going to graph it. So again, domain is the number of terms, term number, position number, so 1, 2, 3, 4, 5, 6. The range is the values, 32, 8, 2, then it was 1/2, 1/8, 1/32. Here's the graph. Notice what it is. It is an exponential. It starts high and starts going low really fast. Alright, so recap. While the graph of arithmetic sequence is linear, the graph of a geometric sequence is exponential. It can be represented by f of x equals r to the x power, where r is a common ratio, has to be more than 1, and r can't be 0. So again, arithmetic is a line, geometric is exponential, and the r functions, the domain is defined by the term number n, contains a set of or subset of positive integers, and the characteristics of those sequences can be used to classify them. So one last slide. Classify these, whether they're arithmetic, geometric, or neither, and explain. So first, let's just test them. This first one, let's see if it's arithmetic. I'm going to try to find the common difference. I'm going to check D. So 24 minus 16, that's 8. I think it's plus 8. So 16 plus 8 is 24. 24 plus 8 is 32, not 36. So no, it's not. There's no D. And I guess to prove that I can do this other one as well. They're different. So no common difference, no D. Alright, let's try other one, geometric on R, common ratio. So 24 over 16, I can divide by 8, that's 3 over 2. So that's my multiplier, but I try the next one. So 36 over 24 divided by 12, it's also 3 over 2, that's good. I'm going to try one more, just make sure all of them are consistent. 54 over 36, and 18, I get 3 over 2. They're all the same. So this one is geometric with the common ratio, r equals 3 over 2. That's our multiplier. Alright, second one, same thing. So let's try seeing if there's a common difference, D. So let's see, 4 minus 1 is 3. So I think we're adding 3. So 1 plus 3 is 4. 4 plus 3 is 7. That's wrong. But just prove it. 9 minus 4, it was 5. Different, though no D. Alright, I'll try the next one. Division. So second one divided by the first is 4. That's my multiplier. 1 times 4 is 4. 4 times 4 should be 16. That's wrong, but I'll try it again. 9 minus divided by 4. That doesn't reduce. They're different. So because it's not arithmetic or geometric, it's neither. So I'll say no R. This will be neither. The reason was no common difference or common ratio. Alright, and the last one. Down here, let's try subtracting. So 17 minus 23 is negative 6. Looks like we're subtracting 6. 23 minus 6 is 17. 17 minus 6 is 11. Good. 11 minus 5 is... Or 11 minus 6 is 5. We're good. So I can check again. 11 minus 17, that's negative 6. And if I do the next one, 5 minus 11, I get negative 6. Because they all match, we have a arithmetic sequence with D equals negative 6. Alright, I'll leave you with this practice problem. There's the answer on the right. Try to classify those 3 on the left, and I gave the reasoning. Thank you for watching. See you in class. Bye.